I have to be honest with you. When I saw the topic for today's deep dive, I had this visceral physical reaction, and it was not a good one. It was that feeling, sitting in a hard plastic chair in ninth grade, staring at a whiteboard and just having absolutely zero idea what was going on.
Let me guess. You saw the word algebra.
I saw the word algebra, and then right below it, I saw the word algorithm. And I just thought, okay, are we punishing the listeners today? Is this remedial summer school? Because, for most people, those two words are just the bane of their existence.
It's funny you say that because you're right. For most of us, those words represent stress, tests, confusing computer code we're told runs our lives.
Exactly.
But when you actually dig into the stack of research we have today, you realize they aren't just dry academic terms. They are, in fact, the legacy of one specific guy.
And see, that was the part that actually hooked me. I always assumed algebra was just, I don't know, a Greek word for headache, or algorithm was some modern tech speak. But you're telling me they both trace back to a single human being.
A single human being. And not, a Greek philosopher in a toga, and not a coder in a hoodie in Silicon Valley. We are talking about a Persian scholar, a librarian, living in Baghdad in the 9th century.
The idea that the source code for our entire modern world, literally the math that lets us stream this audio to you right now, was written down by a guy with a quill pen and a scroll, that is just wild.
It really is. We are diving into the life of Muhammad ibn Musa Al-Khwarizmi.
Oh.
And I think really do that by the end of this,
Yeah.
You're going to stop seeing X as this letter that haunts your nightmares.
I'm not making any promises.
And start seeing it as the tool that really unlocked the modern world.
That is a very tall order, but I am here for it. I'm ready to be convinced. So let's set the scene. We're not in ancient Greece. We're not in Renaissance Europe. We are in the Islamic Golden Age. Who was this man?
So Al-Khwarizmi is born around 780 CE. And to really get a handle on him, you have to understand the vibe of the era.
The vibe, I like that.
Yeah, the Abbasid Caliphate had just taken over a few decades earlier. The capital had moved to the brand new purpose-built city of Baghdad. And there was this explosion of intellectual energy. It wasn't just about conquering land anymore. It was about conquering knowledge.
Right. This is a major pivot in history. And his name, Al-Khwarizmi, that's not a first name, is it? It's more of a descriptor.
Exactly. In that era, names often functioned like GPS coordinates for your identity. Al-Khwarizmi pretty clearly implies he came from a place called Khwarizm.
Which, if I'm looking at a modern map, is where exactly?
It's a region south of the Aral Sea. Today, it's essentially split between modern-day Uzbekistan and Turkmenistan.
Okay.
But back then, it was part of what we'd call Greater Iran, a place with very deep, very old Persian cultural and scientific roots.
But I remember reading in the notes that there's a bit of a historical whoops regarding his identity, something about a typo that messed up his biography for centuries.
Oh, this is a classic historian's headache. That's a great little detective story. So there was a later historian, a very famous one named Al-Tabari, who was cataloging all the famous scholars.
Right.
He writes out Al-Khwarizmi's full name, but then he adds this other tag at the end, Al-Qatrubali.
Which means?
It means someone from Quatrubal, which was a district right outside Baghdad, a sort of wine-growing suburb.
Wait, he's from Central Asia and from a Baghdad suburb.
Exactly the problem. For a long, long time, historians were scratching their heads. They were thinking, okay, is he the guy from Khwarazm or is he the guy from Quatrubal? Because you can't really be from both places at once unless you have a very, very complicated commute.
It's like being called the New Yorker from Texas. It doesn't make sense.
Precisely. But modern scholars, people like Rashti Rasht, went back to the original manuscripts, and they realized something. It's highly, highly probable that a scribe somewhere down the line just missed a single tiny letter, the letter wa.
Which is just the word for and?
Just the word and. It should likely have read Al-Khwarizmi and Al-Majuzi Al-Qatrubali, meaning Al-Tabari was probably listing two completely different people in his catalog.
Wow.
But because someone 1,000 years ago forgot a conjunction, we spent centuries debating where this one guy was born.
Yeah.
It's a humbling lesson in history.
That is terrifying. One typo and your entire identity gets merged with your neighbor. But you mentioned another name there, Al-Majuzi. That's another interesting tag, isn't it?
It is. Very interesting one. Al-Majuzi translates to the Magian, or more specifically, the Zoroastrian.
Wait, hold on. I thought Al-Khwarizmi was this prominent scholar working for the Islamic Caliph in the capital of the Islamic world.
He was, absolutely. And if you read the preface to his book on algebra, it's incredibly orthodox. He praises Allah, he blesses the Prophet Muhammad. There is absolutely no doubt he was a practicing devout Muslim.
So why call him the Zoroastrian? Is it an insult?
It's more likely a reference to his heritage. You have to remember, the Muslim conquest of Persia had happened a century or so before, but the cultural transition was still ongoing. It's very possible his ancestors, or maybe even Al-Khwarizmi himself as a young child, were Zoroastrian before converting to Islam.
It just paints such a rich picture of a melting pot, doesn't it?
Mm-hmm.
You have this person with Persian heritage and Islamic faith living in this new Arab capital, and he ends up working at the most famous think tank in history.
The House of Wisdom, Beit al-Hikmah.
Yeah, and I think calling it a library really, really undersells it.
It absolutely does.
When I hear library, I think of a quiet room with a lady shushing me. This sounds more like, I don't know, Bell Labs meets the British Museum.
That's a much better comparison. This was a government-funded super lab. The Caliph at the time, Al-Mamun, was obsessed, and I mean completely obsessed with science and philosophy.
I heard there was a story about a dream.
The story goes that he had a dream where Aristotle himself appeared to him.
No.
Yes. And after this dream, he became convinced that he needed to gather and translate all the wisdom of the ancients into Arabic. He sent emissaries to Byzantium, to India, everywhere, paying in gold to bring back manuscripts.
And Al-Khwarizmi's job, starting around 820 CE, was to be a lead scholar in this massive operation.
He was the head astronomer and the head of the library, the collection of books. His job wasn't just to stamp books and put them on a shelf. It was to take Greek geometry, Indian numbers, Persian astronomy, and somehow make them all talk to each other.
He wasn't just a translator, he was a synthesizer.
That is the absolute key to understanding him. He's sitting at the crossroads of all these civilizations with all of this knowledge flowing into Baghdad, and that unique position is what allowed him to write the book that changed everything.
Okay, let's get into the book, the big one. I'm going to say the name.
Al-Kitab al-Mukhtar fi Sab al-Jabr wal-Muqabala.
Which just rolls right off the tongue. But hidden in that very long title is that one little word, Al-Jabr.
Yes, Al-Jabr. And that is, of course, where we get our word algebra.
Now, I have always associated algebra with solving for x. That's what it is to me. But what did the word Al-Jabr actually mean to a 9th century Persian scholar? It couldn't have meant math class.
No, it didn't. It's actually a very practical, almost physical term. It means restoration or reunion of broken parts.
I think I read it was a medical term.
It was. The person who set broken bones was a mujabir. So Al-Jabr is the act of setting a bone.
Setting a bone. How does that relate to math? How do you set the bone of an equation?
Okay, so visualize a scale, a balancing scale, or just a simple equation. Let's say you have something like x squared equals 40x minus 4x squared.
Okay, I'm visualizing, and I see a problem. We have a negative term on that right side, that minus 4x squared. It's messy. It's broken, to use your term.
It's a deficiency. In Al-Khwarizmi's mind, a negative term is a hole in the equation that needs to be filled.
Yeah.
So you perform Al-Jabr restoration. You add 4x squared to the right side to get rid of the negative.
But then the scale is unbalanced.
Exactly. Yeah. So to keep the balance, you must also add it to the left side. You are restoring the term by moving it over.
So you're healing the negative number. The equation becomes 5x squared equals 40x. Everything is positive and whole again.
You've restored it. That's Al-Jabr.
Okay, that makes so much sense. So what about the second part of the title, the wal muqabala?
That means balancing or confronting. It's basically reduction, the next cleanup step.
Okay, give me an example.
So say you have x squared plus 14 equals x plus 5. You have plain numbers, constants on both sides. Al-Muqabala is canceling them out. You subtract 5 from the 14 and also from the 5 on the other side.
So you're left with x squared plus 9 equals x. You've simplified it.
You've balanced it. It's just housekeeping, like you said, tidying up the equation.
But why was this considered so revolutionary? I mean, the Greeks had been doing math for 1,000 years. Didn't Euclid or Pythagoras figure this stuff out?
This is the absolute crux of his genius. The Greeks were brilliant, but they had a self-imposed limitation. They were obsessed with geometry.
Meaning shapes, lines, circles, triangles.
Meaning physical shapes. For a Greek mathematician, a number wasn't just an abstract concept. It had to be something you could, draw on the sand. So x squared wasn't just a number multiplied by itself. It was literally a square, a physical shape with 4 sides, and x was a line.
Okay, I'm with you.
So now, Imagine trying to add x squared plus x. In the Greek mindset, you are asking to add a flat, two-dimensional square shape to a one-dimensional straight line.
You can't do that.
You can't. It's physically impossible. It's like asking a construction worker to add a square foot of carpet to a linear foot of fence. It's nonsensical.
There's just different categories of things.
Exactly. They exist in different dimensions.
Yeah.
But Al-Khwarizmi, he didn't care. He had this incredible insight. He realized that if you strip away the geometry, if you just treat these things as abstract objects, you can add them. You can manipulate them according to a set of rules.
So he basically created a virtual reality for numbers. He said, forget the carpet and the fence for a second. In this abstract world I'm building, we can combine these things.
That is the aha moment. That's the paradigm shift. He liberated mathematics from the physical world. He created a unifying theory that allowed rational numbers, irrational numbers, and geometric magnitudes all to be treated as the same kind of thing, algebraic objects.
But here's the thing that really blew my mind when I was reading the research. If I went back in time to 825 CE and opened his book, the compendious book on calculation, I wouldn't recognize it as a math book.
No, you absolutely would not. You'd think you're reading a book of logic puzzles or maybe a legal text.
Because there are no symbols.
None. Not a single one. No plus sign, no minus sign, no division symbol, no equal sign, and definitely no X or Y.
So how on earth do you write an equation? How do you even do this?
He used what we now call rhetorical algebra. He wrote everything out in full descriptive sentences.
Okay, give me an example. How would you write something simple, like x squared plus 10x equals 39?
He would write, and I'm quoting a translation here, a square and 10 of its roots are equal to 39 dirhams.
Roots? Dirhams, what are those?
The root, or shay in Arabic, which means thing, is the unknown. It's Rx.
The thing you're looking for.
Yes. The square is, of course, that thing multiplied by itself, Rx squared. And dirham, which was the local currency, was just used to represent a simple unit, a plain number.
That sounds absolutely exhausting to read and write.
It is incredibly dense. There's a famous problem in the book that goes something like this. If someone says, I have divided 10 into two parts and have multiplied one of them by itself, it is equal to the other taken 81 times.
My brain just short-circuited trying to parse that sentence.
Right. You have to hold the entire logical structure in your head just to figure out what the equation even is. 10 less thing multiplied by itself. But what's amazing is that despite the lack of symbols, his logic was flawless. He categorized every possible linear and quadratic equation into 6 standard forms, and for each one, he gave a step-by-step recipe for solving it.
He created the first instruction manual for solving these things.
The first algorithm, really.
Which brings up a bit of a title fight. We call Al-Khwarizmi the father of algebra, but I've had people tell me, actually, no, it was Diophantus. He was a Greek mathematician living in Alexandria centuries earlier. Why does Al-Khwarizmi get the trophy?
It's a debate that gets pretty heated in math history circles, but it comes down to purpose.
Okay.
Diophantus wrote a brilliant book called Arithmetica, and he definitely solved some very complex algebraic-type problems. But here is the key distinction. Diophantus was interested in number theory. He was solving specific puzzles. He wanted to find specific, elegant, integer solutions to specific riddles.
So he was like a guy who is incredibly good at doing the Sunday crossword or Sudoku.
That's a great analogy. He's a master puzzle solver. But Al-Khwarizmi wasn't just solving puzzles. He was teaching a method. He was the first to treat algebra as a discipline in its own right, for its own sake. He wasn't looking for one specific answer. He was showing you the general theory of how all equations of a certain type work.
So Diophantus gave you a fish, but Al-Khwarizmi taught you how to fish.
Perfectly put. He wrote the textbook, not the puzzle book. The historian Carl B. Boyer said that Al-Khwarizmi's work is much closer to the elementary algebra of today than the works of either Diophantus or the Indian mathematician Brahmagupta.
And it was a textbook with a purpose. This wasn't just ivory tower theory. The Caliph encouraged him to write this book because people had real, everyday problems to solve.
Very real problems. The book is full of practical examples.
What kind of problems are we talking about?
Things like digging canals of a certain volume, measuring the area of different shapes of land for farming or taxation, business deals, trade. But the biggest one, and the one that takes up a huge chunk of the second half of the book, is inheritance.
Inheritance. You need algebra to figure out who gets grandma's antique lamp.
In 9th century Islamic law, oh yes, it was notoriously complex. The Quran lays out very specific fractional shares for every relative. For example, a wife gets 1/8 of the estate if there are children, but 1/4 if there aren't. A daughter gets half of what a son gets. Parents get 1/6 each. It goes on and on.
Okay, I can see how that gets messy really, really fast. Especially if you have a wife, two daughters, a mother, and a brother, and the estate is, I don't know, a farm and 30 camels.
It gets incredibly messy. You end up with these really complex fractional equations where you have to find a common denominator and solve for an unknown share to make sure everyone gets their exact legal right without, having to cut a camel in half.
Right.
Al-Khwarizmi showed, step by step, how algebra could solve these disputes fairly and logically.
So he wasn't just a mathematician. He was essentially an estate lawyer, a surveyor, a trade consultant.
He was providing the foundational tools for the entire legal and economic system to function. It's the ultimate example of applied mathematics.
Okay, so he gives us algebra. He liberates numbers from shapes. He solves inheritance law. That alone is a Hall of Fame career. But we started this whole deep dive with two words, algebra and algorithm.
Yes, and it's fascinating. While algebra comes from the title of his book, the word algorithm comes from the man himself.
It's a corruption of his name, Al-Khwarizmi.
It is. His second great masterpiece was a book on arithmetic. The original Arabic text is actually lost to history, but it survived in Latin translations. The most famous one was titled Algoritmo de numero indorum,
Which means?
Al-Khwarizmi on the Hindu art of reckoning. And the author's name, Al-Khwarizmi, was Latinized into Algoritmi.
And over time, Algoritmi just morphs into algorithm.
It does. And in Spanish and Portuguese, it became Gorismo, which still means digit. His name literally became the word for a number.
So what was in this book that was so revolutionary that his name became synonymous with calculation itself?
Because he introduced the killer app of the Middle Ages to the Western world, the Hindu-Arabic numeral system.
Our numbers, 1 through 9. And the big hero of the story, 0.
The one and only. We take this completely for granted, but you have to try to imagine doing math before this. You're in Europe, you're a merchant in, say, 11th century Italy. You're using Roman numerals.
Ugh, I can barely read the Super Bowl number in Roman numerals. It's a mess.
Now try doing long division. Divide MCMXLV by 14th.
I wouldn't even know where to begin. Is that even possible?
It's basically impossible. It's a complete nightmare. The Roman system was okay for recording a number once you had it, but it was terrible for actually calculating with it. Al-Khwarizmi's book explained the Indian system of place value.
The idea that a 1 in the tens column is worth 10 times as much as a 1 in the ones column?
Yes, and that system only works because of the 0. It's the placeholder that makes the whole thing click.
The ultimate game changer.
And he didn't just explain the numbers. He described a specific way to do these calculations using a tool called a tack.
A dustboard. Tell me about the dustboard, because this is where I think the connection to modern computers really becomes clear.
So paper or parchment was incredibly expensive. You didn't want to waste it on scratch work. So people used a wooden board covered in a thin layer of fine sand or dust. You would write your numbers in the sand with a stylus.
Okay, like a primitive whiteboard.
Sort of. But here's the key feature. When you did a step of a calculation, let's say you're carrying the 1 in addition, you would physically erase the old number with your finger and write the new result in its place.
You're overwriting the data in its memory location.
You are literally overwriting the data. Unlike an abacus, where all the beads stay there, the dustboard had a dynamic updating state. You erase the input to create the output step by step.
That is precisely how computer RAM works. You have a memory address, you write a value to it, you perform an operation, and you overwrite that address with the new value.
The parallel is astounding. He was teaching people how to process information in a step-by-step, mechanical, repeatable way. Step 1, write the numbers. Step 2, add the rightmost column. Step 3, erase the operands and write the result. Step 4, carry the 1. That recipe. And that is an algorithm.
And the people who adopted this newfangled method in Europe were actually called algorists?
They were. And for a while, they were the rebels. They were the cool kids with the new tech.
Was it controversial?
Oh, hugely. For centuries, there was a war between the algorists and the abacists, the people who were masters of the abacus and wanted to stick to the old ways.
I absolutely love the idea of a medieval turf war between math nerds. Guys with beads versus guys with sandboards.
It was real. The abacists argued their method was more reliable, less prone to error. But the algorists eventually won because their system was just so much more powerful and efficient, especially for multiplication and division.
And it all came from this one source.
So much so that in the Latin manuscripts that spread through Europe, the text often began with the powerful phrase, Dixit Algoritmi.
Thus spake Al-Khwarizmi.
It sounds biblical, doesn't it? It has the weight of a commandment from a prophet. Do it this way because Al-Khwarizmi, the master, said so. His name itself became the authority on calculation.
So every single time a programmer writes a line of code today, or Amazon servers recommend me a pair of shoes I don't need, they are unknowingly invoking the name of this 9th century Persian librarian.
It is a direct line of descent, no question.
But he didn't stop at math. I mean, if you suddenly have this new superpower, this ability to calculate things that no one else could before, you're going to want to apply it to everything.
And he did. He looked up at the sky.
Astronomy.
His third major work was the Zaby is basically a book of astronomical tables.
And that word Sinthind, it sounds Indian.
It is. It's a corruption of the Sanskrit word Siddhanta, which means a similar kind of astronomical treatise. So again, you see Al-Khwarizmi as the synthesizer.
So he's not inventing astronomy, he's upgrading it.
He's taking Indian astronomical methods and data, mixing them with the Greek Ptolemaic model of the universe and Persian observational traditions, and creating this massive, comprehensive guide. It had 37 chapters and 116 tables, with data for the sun, the moon, and the 5 known planets.
But wasn't everyone doing star charts back then?
They were. But Al-Khwarizmi's Z introduced something new and powerful to the Islamic world in this book: trigonometry.
Sines and cosines. Oh no, more high school math trauma.
But this was a huge deal. For the first time, he included accurate tables for the sine and cosine functions. This allowed for much, much more precise calculations of planetary positions, the timing of eclipses, you name it.
So this was another level-up moment.
A huge one. Before this, Islamic astronomy was mostly just translating and preserving older texts. After Al-Khwarizmi's Z, it became a true research field. Later, astronomers started using his methods to check the math of the ancients, and they began finding errors.
And once you start correcting the ancients about the heavens, you probably start wondering if they were wrong about the Earth, too.
Exactly. Which leads us to his fourth great work, his geography. He wrote the Kitab Oriyat Alar, the image of the Earth.
And the ancient he was correcting here was the big one, Ptolemy.
Ptolemy was the gold standard for geography for over 1,000 years. But his maps had some pretty serious problems. Al-Khwarizmi, under the patronage of the Caliph, oversaw a massive state project, a team of 70 geographers, to revise and remap the known world.
70 geographers. That's a serious budget. What was the biggest thing they fixed?
The number one error was the size of the Mediterranean Sea. Ptolemy had estimated the length of the Mediterranean from the Pillars of Hercules to the eastern shore to be about 63 degrees of longitude.
And is that wrong?
It's way, way too long. It stretches Europe and Africa out like they're made of taffy. It completely distorts the shape of the continents. Al-Khwarizmi's team recalculated it to about 50 degrees.
That's a massive correction, more than 20%.
It is. The modern value is about 42 degrees, so he wasn't perfect, but he was so much closer than the Greeks. He got the scale of the world much more correct.
And I read something about the oceans that really struck me. Ptolemy thought the Indian Ocean was a lake.
That's right. In Ptolemy's world, the Indian Ocean and the Atlantic were depicted as giant, landlocked seas. They were surrounded by unknown lands, terra incognita.
Which is such a confining worldview. It means you're trapped. There's nowhere else to go.
It means there is no sea route around Africa. It means the world is fundamentally a closed system. Al-Khwarizmi corrected this. In his work, he depicted them as open bodies of water.
And that's a total paradigm shift. If the ocean is open, you can sail it, you can explore it, you can trade across it.
It completely changes the economic and political imagination of the world. And what's so cool is that even though the original maps from his book were lost to history, we still have his data.
Just the raw numbers.
Yes. The book contains a list of 2,402 coordinates, just pages and pages of latitudes and longitudes for cities, mountains, rivers. And in the 20th century, a scholar named Hubert Donnick plugged all those numbers into a computer to reconstruct the map.
Wow.
And when you see it, it looks recognizable. You can see the coastline of India, the Mediterranean. It looks like our world, but seen through the mathematical lens of the 9th century.
It's amazing. He's fixing the map of the earth, the map of the heavens. He's fixing the legal code. I even saw he did work on the Jewish calendar.
He did. He wrote a separate treatise on the Hebrew calendar called Risala fi Istiklaj Tariq al-Yahud. He calculated the Metonic cycle, that's the 19-year cycle used to align the lunar and solar calendars, and determined the rules for when the first day of the month of Tishrei would fall.
That just speaks to his incredible intellectual curiosity. Here he is, an Orthodox Muslim working for the Caliph, but he's diving deep into Hebrew timekeeping, Indian numbers, Greek geometry. He really didn't care where the truth came from, did he?
He was the ultimate pragmatist.
Yeah.
If a tool worked, he used it. If a number system was better, he adopted it. And that open synthetic attitude is what ultimately saved this knowledge for the rest of the world.
So let's talk about that survival, that transmission, because Baghdad has a rough few centuries coming up. The Mongols sacked the city in 1258. The House of Wisdom is destroyed. The Tigris River supposedly runs black with the ink of all the books thrown into it. How do we know any of this?
We got incredibly lucky. Before the destruction, the knowledge had already leaked out. In the 12th century, there was a massive translation movement in Europe, specifically in Spain.
Right, because much of Spain was under Muslim rule for a long time. It was a cultural bridge.
Toledo, especially, was a hub where Christian, Muslim, and Jewish scholars all mixed. And you had these ambitious European scholars, guys like Robert of Chester and Adelard of Bath, both Englishmen, traveling to Spain, specifically to hunt for these Arabic manuscripts.
It's a reverse intellectual commute. We usually think of knowledge flowing from Europe outwards. Here you have Englishmen going to Spain to translate a Persian's book, written in Arabic, so they can learn how to do basic math back home.
And when Robert of Chester translated Al-Jabr into Latin around 1145, it exploded.
Right.
It became the principal mathematics textbook in the new European universities.
For how long?
Until the 16th century.
Wait, say that again?
For 400 years.
That is just... It's almost impossible to wrap your head around. That's like us today using a science textbook written in the early 1600s.
It just shows you how completely foundational and revolutionary his work was. You literally could not do the advanced science of the Renaissance without it. You don't get Copernicus, you don't get Kepler, you certainly don't get Newton without Al-Khwarizmi first providing the basic language of calculation.
And the world has recognized this, right? I mean, we talked about his name becoming the word algorithm, but there are actual physical monuments.
There are. There is a crater on the far side of the moon named Al-Khwarizmi,
which is very fitting for an astronomer.
There are a couple of asteroids named after him. There are statues of him in his ancestral homeland of Uzbekistan, where he's a national hero, and even one in Madrid. But I think his real monument is invisible.
What do you mean by that?
I mean the layer of abstraction that he placed over the entire world.
Explain that idea.
Before him, math was tied to the ground. It was about counting sheep or measuring a physical field. It was concrete. Al-Khwarizmi was the one who built a layer above that, a layer of pure symbols, of pure logic, thing and root and square.
He separated the software from the hardware.
That is the perfect analogy. He separated the logical software from the physical hardware of the world. He was the first to show, in a systematic way, that you can understand and manipulate the world not by moving rocks, but by manipulating symbols. That is the essence of computer science. It's the essence of modern physics. It's the essence of everything.
It brings us right back to that phrase, Dixit Algoritmi.
Thus spake Al-Khwarizmi.
It really is a provocative thought to end on then. If those books hadn't been translated in the 12th century, if Robert of Chester had decided to stay home in England, would we even have had a digital revolution?
It's the great what if of scientific history. We might still be using the abacus. We might still be stuck with Roman numerals, struggling to calculate simple interest on a loan. The incredible acceleration of human progress over the last 500 years depends so heavily on these synthesizers. These unique people who can stand at a crossroads, take disconnected ideas from different cultures, and forge them into a single, powerful, usable tool.
So the next time you open your laptop, or you get frustrated with an algorithm that feeds you the wrong song, or, God forbid, you actually have to solve for X, maybe just take a second to nod to the librarian from 9th century Baghdad.
Muhammad ibn Musa Al-Khwarizmi.
The man who wrote the source code for the modern world. Thanks for diving deep with us. We'll catch you on the next one.